Hello everyone, my name is Umaira Banu. I'm currently in my second year of studying computer science and engineering at Srinivasa Ramanujan Institute of Technology. Today I'll be discussing about demultiplexers in digital logic and computer organization. So let us see the overview of my topic is introduction, types, I see as demultiplexers, advantages, disadvantages, applications and conclusion. Right, starting from introduction. Introduction was the definition. What is a multiplexer? Multiplexer is one of the type of combinational circuits which involves taking a single input and producing multiple outputs. Its main function is to route input signals to one of the multiple outputs based on a control signal. So this is a simple diagram of how the multiplexer look like. It is an example of combinational logic circuit. It accepts a single input and distributes 2 power n lines of outputs where n involves the number of select lines. Instead of calling demultiplexers, it is so long, right? So instead of that, we'll use demux in short for mentioning demultiplexers. It is used to transmit same data to different destinations. So in this sense, it is also known as data distributor. It performs opposite operation, quite opposite operation to multiplexer. If the enable pin is active low, which means 0, then the total circuit will be in off condition and the inputs given at that time are considered as no care condition, and when it is active high then the circuit will be in on condition and all the inputs are considered only when the enable pin is given 1, whereas when it is given 0 it all outputs, all the inputs given during enable pin 0 are not considered here. So these are the n select lines and the output is based on the number of n select lines here. Moving to types of demultiplexers. Demultiplexers are classified in what basis and how many of them are there, we'll be knowing using this slide. Based on the number of output lines, that is 2 power n, demultiplexers are classified into several types. Some commonly used are mentioned here like 1 is to 2 Dmax, 1 is to 4 and 1 is to 8. These are only some and there are a lot of I have not mentioned that those. Let us see this one by one somewhat briefly. 1 is to 2 Dmax. It only consists of one input line, one select line, and two output lines. So these is a simple diagram of 1 is to 2 Dmax. This is the input line which is only one in number, and this is the select line. These are the two different outputs, that is Y1 and Y0, and the upper one is the enable pin. As I have mentioned that if the enable pin is active low, which means it is in 0 off condition, the total entire circuit will be in off, whereas when the enable pin is given 1, then it works on the basis of given inputs. The logic level applied at a select line determines the output line to which input data can be transmitted. So these are the truth tables and logical diagrams of 1 is to 2 Dmax. From this logical diagram, we'll be writing the logical expression like y0 is equals to s0 bar into a and y1 is equals to s0 into a. Basing on these truth tables, we can construct the logical diagram, and from logical diagram, we can write the logical expression as follows. 1 is to 4 demultiplexer is another type of multiplexer, demultiplexer. It takes a single input and channels it into one of the 4 outputs based on the selection lines. 4 outputs labeled Y0, Y1, Y2 and finally Y3. There are 2 selection lines, those are S1 and S0. So this is the example diagram, like this is S1 and S0 or the 2 select lines, and these are the 4 different outputs of 1 is to 4 Tmax. And this is the truth table as well as the logical diagram from which logical expressions are derived. So when y0 is 1, so we'll consider those situations, that is S0 bar, and let's keep in mind that if the selection line is 0, which is considered as a bar above the select line. So like this, see here, in y0 is equals to s1 bar, s0 bar, and into a. Here, when y0 is equals to 1, both the s0 and s1 are in of, that means 0 0. And the second one is y1 is 1. When y1 is 1, s0 bar, s1 bar, s0, and a. See, the same here I have mentioned. And y2. Y2 is 1 when s1 is 1 and s0 is 0. The same will be writing here in logical expression. And as well as from the truth table, what we have mentioned here, the logical diagram also been constructed by using this one. So, these are our select lines, and this is the NAND gate. This is the AND gate from which the different outputs are emerged. This is the third type of demultiplexer, that is 1 is to 8 demux. This 1 is to 8 demux was designed by using 2 demux. There are totally 8 number of outputs. Those involve y0, y1, y2, y3, y4, and so on to y7. It consists of three different types of selection lines, which are S0, S1, and S2, and one single out input. As I have told you that it accepts only a single input and produces multiple number of outputs basing on the number of selection lines. So this is the main motto in demultiplexers we can mention. On the basis of combination of inputs we are present at the selection lines S0, S1, and S2, the input will be connected to one of these outputs. So this is the truth table, as there are more number of outputs from y0 to y7, which means there are 8 number of outputs. So the truth table will be somewhat larger. And the three different selection lines S0, S1, and S2, similar to I have mentioned in 1 is to 4 demultiplexer. When y0 is equals to 1, the corresponding selection line statements are considered for writing the logical expression. And see here, when y0 equals to 1, the selection lines S0, S1, and S2, the three are in off, which means those three are in 0. Here in logical expression, we have to mention that S0 bar, S1 bar, and S2 bar. So let us see how I have mentioned in logical expressions. And these logical diagram is constructed with the help of that previously shown truth table. And these are the logical expressions from those truth table and this logical diagram. There are 7 different outputs from y0, y1 to and so on up to y7. So integrating circuits working as demultiplexers. Demultiplexers can also be built in the form of integrated circuits, which means ICs in short form. There are several types of ICs available that work as demultiplexers. Some of the examples I have mentioned, like 74139 IC works as 1 is to 4 demultiplexers, and 1 is to 8 demultiplexers can be mentioned from 74237 IC. And 74154 IC works as 1 is to 16 demultiplexer. So these are the three different multiplexers with the corresponding ICs, how they works together like a similar, having similar functions. So some of the advantages of demultiplexers, they have high efficiency, compactness, simplicity, and as well as it will be having flexibility, integration, and scalability. We have large number of advantages of demultiplexers. It also consists of disadvantages, as everything is having advantages must and should have some disadvantages, right? So in the same manner, advantages also overcomes some disadvantages like complexity, propagation delay, power consumption, limited outputs, as well as noise sensitivity. Complexity involves increased circuit complexity for larger configurations. As I have mentioned the truth tables, right? From 1 is to 2, 1 is to 4, and 1 is to 8, the complexity of these truth tables have been going on increasing, right? I have not mentioned that 1 is to 16. It will be having some more larger truth table. Like 1 is to 2 will have 2 outputs. 1 is to 4 will have 4 outputs, and similarly 1 is to 8 will have 8, and finally 1 is to 16 may also have 16 number of outputs, which making the circuit to be more complex. So this is one of the type of complexity, uh, the complexity coming under disadvantage. And the next one is propagation delay. It can introduce delays in signal transmission, right? And the third one is power consumption. It may consume some more power, especially for large designs. Yes, like designs for 1 is to 8 and 1 is to 16, it might consume some more power. So this is the one type of disadvantage we can mention. So limited outputs, fixed number of outputs based on the design. So let's suppose only they will be produce only the limited outputs. Like 1 is to 2 only provides only 2 outputs. 1 is to 4 will provide only 4 outputs. So this is the limited output disadvantage. And the last one is noise sensitivity. It can be sensitive to noise and speed applications. So these are the different types of disadvantages. Is having more number of applications, like they're used in several input and output devices for data routing. And the second one is digital control systems to select one signal from a mutual stream of signals. So I have mentioned in picture that one single source when connected to demultiplexer, that is selected, it may be connected to more number of outputs like a Bluetooth speaker, fax machine, printer, smartphones, and many more based on the type of demultiplexer we have used. And there are more number of applications which involves utilized in data acquisition systems and for generating boolean functions, serial to parallel converters, in used for broadcasting of ATM packets, and used in design automatic test equipment, and many more. There are a large scale of applications of demultiplexers. So finally, moving to conclusion, DMUX is a data distributor combinational circuit. It works in a reverse process of multiplexer. It accepts one input and produces multi-number of outputs. It increases the efficiency of a particular communication system as it takes data from a specific input source and distributes to different sources. But DMUX may cause a wastage of bandwidth as it distributes the refined data in different channels, right? So these channels can overlap with each other, which leads to the loss of signal. DMUX helps to save the output of ALU, which is arithmetic logic unit. The output will be saved in the registers and the various storage units of system. So thank you for listening to me.